Hello and welcome back. We'll finish up section 3.1 in this video by looking at some applications. So we'll have an archer fires an arrow and it follows a parabolic path through the air. And the height of the arrow is given in terms of how far it's traveled. So with this function, this is a quadratic function. So the further it travels x, we can calculate its height by plugging in how far it's traveled x into our function. So it asks some questions. What is the maximum height, and where does it occur? We'll find how far the arrow travels before it hits the ground, and we'll just graph the function. So again, to find a maximum, we're looking for the vertex of the graph. So again, roughly, this will be higher. This will be fired from some height. It'll go up into the air, and then it'll come down. So what we want is going to be the vertex, the maximum height. So again, the x value for where this happens is going to be negative b over 2a. So if we come back up to our function, negative b is going to be, so b is 2, so it's going to be negative 2 over 2 times a, and a is going to be negative 0.005. So when we multiply this out, we'll get negative 2. This is going to be negative 0.01. And when we cancel out the negative signs, divided by 0.01, this is 1/100th. So the maximum height will occur at after the arrow has traveled 200 yards. But then what is the height? Well, at that point, after it's traveled 200 yards, we can just plug this in to find out. So it'll be 200 squared plus 2 times 200 plus 5. So we can start simplifying this. 200 squared will be 4 with 4 zeros, so 40,000 plus 400 plus 5. Multiplying this out, so this is 4 times 10 to the 4th times negative 5 times 10 to the 3rd power. So when we multiply these, we'll get negative 20, the negative 3rd power times 10 to the 1st power. This is going to be minus 200 plus 400 plus 5. Minus 200 and 400 is 200, plus 5 is 205. So this is the height. This is the max height of the function. As in, this is the peak of the arrow's path will be 205 yards up after it has traveled 200 yards. So this peak up here is going to be 205. Now, to figure out where the arrow hits the ground, well, we know that the height of the function when it hits the ground is going to be 0. So what we are doing is we want to solve for the, I should show this, is we want to solve for the x-intercept right there. So we want 0 is equal to this big mess. 005 x squared plus 2x plus 5. Yep, so that's our function. So we want the height to be equal to 0. So I will simply use the quadratic formula to give x is going to be equal to negative 2 plus or minus the square root of 2 squared minus 4 times a, so this is negative 0.005 times c, which is also 5, all divided by 2 times a. And this is something that I'm just going to plug into a calculator. And what you'll notice is that when we add and subtract these values here, we're going to get both a positive number and a negative number. Well, the positive number is the one that we want, because the negative solution would be if we fired the arrow backwards. And this is not the solution that we want. We want the positive solution after the arrows traveled forward. So this rounded to the nearest foot is going to be 805, or sorry, to the nearest yard. So this is going to be how far the arrow will travel. And then 3 just asks us to graph the formula, which we can. So if I go 1, 2, 3, 4, so if I call these, if I'm doing this in increments of 200, and if there's 200, we said that the maximum height is reached up here at 0. So this is going to be roughly our parabola. So again, we can model physics using this, but then we can also do some more abstract things. So among all pairs of numbers whose difference is 8, should be is 8, find a pair whose product is as small as possible. What is the minimum product? Okay, so we're trying to find a minimum of something, and given the chapter that we're in, this is going to be for a quadratic equation. So find the minimum of a product of 2 numbers. I don't know which 2 numbers they are, so for the moment I'm just going to call them x and y. So the product is what I want to find that's as small as possible. So if I call the product of x and y p, p for product, I want this to be as small as possible. So I want to find the minimum of x times y. So I don't have a whole lot to go on here, but what I do know is that we're looking at pairs of numbers, x and y, whose difference is 8. So we also have one more bit of information. We know that the difference of x and y is going to be 8. So what this means is that I can solve this. For let's say x. If I add y to both sides, I will get x is going to be equal to 8 plus y. So I have this piece of information. This is the product, and this is what I am trying to minimize. I also know that the difference of x and y is going to be 8. So x is going to be 8 more than y. And now what I can do is I can substitute this information into my original expression. So now the product of my 2 numbers is actually going to be, so if I replace x with 8 plus y, I'm going to have 8 plus y times y. And this is what I want to find the minimum value of. So this is what I want to find the minimum of. So let's expand this. So if I distribute, I get 8y plus y squared. This is normally written in the other order, so I'm just going to exchange these just so that it's a little bit easier to see. So I've got y squared plus 8y, and this is going to be a parabola. I know that the parabola is going to, because a is going to be 1, the parabola is going to open upward. So this will have a minimum somewhere. So the question is, where is the minimum value? Well, the minimum value is going to be at negative b over 2a. So this is the vertex. So at negative b over 2a, negative b is going to be at 8, negative 8, and then 2 times a, so this is going to be, 2 times a is just 1 here, so we've got negative 8 over 2 is going to be negative 4. So this is going to be y. This is what we have solved for right here. Now, we also know that if y is going to be negative 4, x is going to be 8 plus y. So x is going to be 8 plus y. This is going to be 8 plus negative 4, which is going to be 4. So what are the values of x and y? They're going to be negative 4 and 4. So what is the minimum product? So the product, which is just going to be x times y, is going to be negative 4, is going to be 4 times negative 4, which is negative 16. So let's summarize. The pair of numbers is going to be 4 and negative 4, and the minimum product is negative 16. And we did this by writing down 2 equations. We knew that the product of 2 numbers was what we were trying to minimize, but we knew the relationship between the numbers. One number was 8 bigger than the other one. So we can rewrite it as a quadratic equation, which we can easily minimize. Let's do one more example. We have 100 yards of fencing to enclose a rectangular region. So we're going to fence off a rectangle of land. Find the dimensions of the rectangle that maximizes the area. Okay, so if we call these x and y, we want to find the area of this. Well, the area of a rectangle is just going to be x times y. So then the question is, what is the maximum area? And we also want to find the dimensions. So right away, we know that we're going to maximize the area, and the area is going to be x times y. So this is what we want to maximize. However, we only have 100 yards of fence. So to stretch all the way around all 4 sides, we only have 100 yards of fence to use. Well, the perimeter of a rectangle, well, we have 2 sides that are x long and 2 sides that are y long. So the perimeter, which has to add up to 100 yards, is going to be, well, we've got 2 side lengths that are x long, and we've got 2 side lengths that are y long. So using this, we can describe a relationship between x and y. So let's do this. I'm going to try to solve for y exactly. So let me write down this equation. We'll subtract 2x from both sides to get 100 minus 2x is equal to 2y. And I'll divide both sides by 2 to get that y will be equal to, on this side, it's 50 minus x. So if we have 100 yards of fence, we know that one of the side lengths is going to be 50 minus the other side length. But we're trying to maximize the area. So we will plug this in. So the area is going to be